Hello friends, welcome to Edwiki Learning channel. Please do subscribe to get more updates on the DevOps concepts. This video is part of the full course AWS DevOps Practitioner Training. Please do check the description below to get the link for the complete full course. Without further delay, let's get into the video. Thank you.
I think we were talking about how to deploy the ingress controller in place, right? So, of course, we can access the application that is running in the Kubernetes cluster from outside of the Kubernetes cluster, right? Using the Kubernetes service of type node port or Kubernetes service of type load balancer, correct? Kubernetes service of type node port is not recommended because we need to uh, go via the specific worker node IP. Even the Kubernetes service of type load balancer is also not recommended because for every service we need to have its corresponding load balancer. So how many services that you have running in your cluster, right? Probably you would need that many number of AWS load balancer, which will be increasing the budget and the maintenance, more number of load balancers at your AWS, lot of stuff, correct? Hence the reason, right? Now we are introducing the ingress controller in place, correct? And the other challenging that was there with the previous approaches, right? You need to have multiple node ports, unique node ports, correct? So we are introducing the ingress controller in place, which will be eliminating all those overhead. Just to call out one more time, the AWS load balancer we are using only for the purpose of routing the traffic from outside of the Kubernetes to inside the Kubernetes. That's it. How that is happening? The AWS load balancer can route the traffic to the node port of a worker node. Then that node port will take care of, I meant to say, the Kubernetes will take care of, you know, getting the traffic on the node port and giving it into the service. Then service will take it up next level, right? Now, so let's see how the ingress controller can be deployed. Before I get into the ingress controller, right, I wanted to talk about a few other concepts which will be really needed before I go and deploy the ingress controller, which is called as a Kubernetes RBAC concept. RBAC is mean that the role-based access control concept, right? I'll talk about this in a while. I'll be keep asking you some of the questions, guys, as when I'm going, or I'm remodelizing my architecture further, right? And help me out in the chart window too. So at a nutshell, right, I have the API server, right? And what's happening this? I don't want this slide to be. So before that, I need a different slide. This is the one. The order is important, right? So I have the API server that is currently running in our Kubernetes cluster, right? So all what I need to ensure is you as a Kubernetes administrator, in order to connect to the API server to administrate your Kubernetes resource deployment, you need to use the kubectl client utility. The kubectl client utility can be installed anywhere else as long as the kubectl is able to connect with the API server. The kubectl can be installed anywhere. Agree with me, guys? As long as the kubectl having the connectivity with the API server, then the kubectl can be installed anywhere, no issues. It's your responsibility to ensure that the connectivity is given to the API server based on public or private, whatever it is. The kubectl client software can be in your local system. The kubectl client software can be in any one of the EC2 instances as well, just to call out. if the kubectl is being used in your local system, then probably most of the cases you will be using the IAM user credentials like access key and the secret access key in order to generate the kubeconfig file that the kubectl will be using for authenticating the API server. Correct? I did the same thing, right? So the kubectl would need the kubeconfig file, right? How that kubeconfig file got generated? The kubeconfig file got generated using the access key and the secret access key, correct? Because I used to run AWS EKS update-kubeconfig. That command is generating the config file, right? That's why I'm saying that the IAM user's access key, secret access key is being used in your local system in order to generate the required config file that has the required certificates that would be needed to authenticate the API server. Help me guys at this time. Once the kubeconfig file is generated, then do I need to worry about the access key, secret access key, or any of the AWS? No, right? Because the kubectl is directly connecting to your Kubernetes. As long as it has its own certificate file, that is good enough. Good. So the same way, if you are using the kubectl client in your EC2 instances, probably since EC2 instances can be having the access key, secret access key configured, or sometimes the EC2 instances can also have the IAM roles, right? Possible. So we can use either the IAM role or you can use a user-based access key, secret access key to generate the kubeconfig file, and the kubectl will use that kubeconfig file and will be connecting to the API server. So far, so good. Let's say, okay, let's say I have a application that is running inside a Kubernetes as a pod, right? So I have an application that is currently running inside a pod. Sometimes we may need to have some requirement that the kubectl client I may need to run inside a pod as well. Following me? Sometimes you need to run the kubectl client commands inside a pod as well. Probably from this pod, I need to connect it to the API server to do some of the Kubernetes administrative related activities. Getting me, guys? Like sometimes, from the EC2 instance itself, you will be running the AWS commands to connect it to the AWS via programmatic way to manage the AWS resources, correct? We did it that previously, right? So we may need to run kubectl client inside a pod as well, right? We may need to run a kubectl inside the pod as well, and that will be connecting to the API server to administrate the effort. If then, how would this kubectl will be getting the required authentication certificates in order to connect and authenticate the API server? So there's a slight difference, right? The kubectl that is running outside of the Kubernetes, the kubectl that is running inside the Kubernetes, correct? When I say the kubectl is running inside the pod, at high level, I can say that it is running the kubectl inside the Kubernetes itself, correct? Right? So the way how I'm granting the permissions to run the kubectl client inside a pod will completely differ. When the kubectl client is running inside a pod, I would say inside a Kubernetes itself, then I don't need to give the API server, the certificate kubeconfig file, all these things not needed, right? Just to correlate, right? So usually, if you would like to run AWS CLI commands inside the EC2, what was the easiest and better approach, guys? IAM role, right? Because on that situation, The EC2 instance is actually the one of the AWS resource itself. So it's very easy to grant the permissions using the role-based access, correct? Similarly, if the Kubernetes client is running inside a Kubernetes only, that may need access to the API server to do some administrative activities, then we may need to use the concept called service accounts. Kubernetes service account is the concept which will be allowing us to grant the permission to the Kubernetes pods to get access to the API servers for any kind of administrative activities. How that is going to work. So let me introduce you the Kubernetes RBAC concept, which is the role-based access control system. The RBAC will give the facility to connect, or the RBAC will help us to grant the role-based access to access the API servers. So in the RBAC, right, you need to create a role first, the Kubernetes role. To the Kubernetes role, you need to give what kind of the permissions that you would like to give. In general, what are the different permissions that you know so far on Kubernetes resources, guys? And first of all, what does it mean by a Kubernetes resource? What are the examples of Kubernetes resources? Pod is one of the Kubernetes resource. Deployment is one of the resource. Service is one of the resource. That means in the manifest file, in the kind section, whatever you define, right, all those are actually the Kubernetes resources, including the replica set. Of course, the namespace, everything is Kubernetes resources. On these Kubernetes resources, we can apply a get command to get the list. We can apply the list, watch, delete, create, update, patch. These are the pretty much top different actions that we can do on the Kubernetes resources, right? Let's say you can run a kubectl get command, right? Kubectl get pods. That means what? We are trying to get the list of the pods. Kubectl describe pod. That is where you would like to list the characteristics of the pod. Kubectl delete pod. That is where all trying to delete a resource, something like this. Kubectl create to create some resources. Kubectl update to update the existing resource configuration. Kubectl patch is again like modifying the existing values, something like this, right? So whichever the permissions that you wanted to give, you define those permissions and give that permissions to the role, and you create a role out of it. Right? Once the Kubernetes role is created by defining what kind of the permissions that you wanted to give based on the requirement, then you need to create a service account. The service account is the concept of, right, is the concept of giving the permissions to the pods. So you need to, the step one, you need to create a Kubernetes role. Step two, you create a service account. Then the step three, you need to create a role binding. Role binding is the concept of attaching the role with the service account. That's it. The role binding purpose is just to combine, just to map which role should be used by which service account, right? That mapping will be done by a role binding. Sometimes one single Kubernetes role can be used by multiple service accounts as well. Of course, if you would like to compare or correlate this concept with your AWS level, right? So like in AWS, in order to give the permissions to the AWS resources, you need to create a IAM policy, IAM role, right? Same concept, right? The IAM policy is equivalent to the get, list, watch, delete kind of permissions. IAM role is equivalent to a Kubernetes role. The service account is equivalent to, like, maybe a IAM user, something like this, and you are just binding the resources here. So whichever the service account that you created, that service account now has to be mapped to a specific pod. That means which pod should get the permission, which pod should get the permissions. To that pod you need to attach a service account. This service account is role binded to which role. That role is attached with what kind of the actions or permissions. So those list of permissions will now be applicable or done by or given by this to this pod. That's how it works. Now in this pod, if you run a kubectl commands, that kubectl command will be gaining the permission to run this list of commands, guys. That's how it works. Right? So now from this pod, whenever you run the kubectl client utility commands, then it will be connecting to the API server, right? And the API server will start doing the administrative activities. From the RBAC concept perspective, the service account is called as a subject, right? So that's just a terminology, a technical terminology, right? Now in this pod, let's say if you run kubectl commands, it will connect it to the API server, and obviously API server will be listening to your kubectl, right? Whatever you instruct, accordingly the API server will go and start deploying the resources for you. Let's say in the pod you run a kubectl command to deploy the deployment on the specific namespace as an example. So that instruction will be given to the API server. API server will go and start deploying the deployments on the specific namespaces that you have been asked for, something like that. The advantage here is, right, to this service account we can restrict the access can be given for which namespace as well. Let's say if I tell that, hey, the access should be given for only a dev namespace, then using the kubectl client on your pod, right, it can manage the resources only on the dev namespace. It cannot manage something on the production namespaces. So the advantage here is we can restrict the list of Kubernetes actions can be done on which namespace as well. We can define it at a namespace level, or you can define at a cluster level as well. When I say cluster level, give the access for all the namespaces, the whole cluster possible. Or we can say that, hey, this has to be a specific namespace only. Based on the requirement, right? We can restrict what kind of the permission and what resources that this can be managed. Whenever you are giving this service account access to the Kubernetes pod, thinking that this pod now can have an access to the API server where the Kubernetes, sorry, in which cluster that it is running in, you may be thinking that why do I need to do all of this? Why should I be running the kubectl from the pod level itself, correct? But the whole idea here is not for the Kubernetes administrators, guys, right? The whole idea here is not for the administrator. If this is for administrator, why should I be struggling to give the permissions to the pod, then you go inside the pod, then you run the kubectl command? No, right? You can always run the kubectl command outside of the Kubernetes cluster as well, the way how we are doing as of today. So this whole exercise is not for administrators. Whenever you give the permissions to the Kubernetes pod to access the API server, sometimes a application that is running inside the pod, that application may need access to the API server to do certain administrative activities. Following me? Right? The application that is running in the pod that may be connecting to the API server to do certain job responsibilities, and that situation it may take the help of the service account to get a permissions to connect it to the API server and do all the different stuff. That means In the pod, technically, I'm not going to install the kubectl also. I don't need to. Why? I'm not using the kubectl in the pod as a Kubernetes administrator, correct? The application is going to connect to the API server and it needs some permissions. That's the reason I'm going to give the service account. Of course, if you can download and install the kubectl client software in the pod, yes, you can go and run the command, not a worry. But why do you need to worry running the commands manually on the pod itself? You can run anywhere else as well, right? If you wanted to connect it to the API server. So the purpose is the application has to connect it to the API server, and if the service account is given, it can connect to the API servers. If application has to connect, it don't need a kubectl client software, guys, because application know how to connect it to the API server using a different technique altogether. So far so good, right? Now,
No, but one question here. Irrespective of the role binding service account, we have to install the kubectl client, right, inside the application. And that we can do using a Docker file, correct? When we create a customized Docker file, we can always say that, okay, download that and install that kubectl.exe or whatever the binary, depending on the.
yes, that's what I'm trying to. If you want the kubectl to be available in the pod, yes, you define the kubectl installation process in your Docker file and you build the image out of it. Then the new image will get the kubectl software and you can run the commands as well. But you don't need to. Why do I need to keep the kubectl inside the pod? The kubectl is just for the administrator has to run. Like if I want to run the command, then I need a kubectl client software. But why do I need to run the kubectl commands inside the pod, correct? Technically, there is no requirement like that. If I want to run kubectl to connect it to API server, I can run it anywhere else as well. I can run in my local machine or I can run in EC2 instances or somewhere else as well, right? If the application that is running inside the pod in your container, if that application wanted to connect to the API server for any administrative activities, then the application don't need a kubectl client software to be installed and available there. The application can connect using the using the APIs or using the modules or the programmatic way in a different way manner. So technically speaking, the applications can connect using the API concept. It don't need the kubectl to be available there because that is just for administrators to run manually. Now I'll call out why the application need to connect to API server to do certain things here. What kind of the job responsibilities that the application is doing? What kind of the applications usually need to have an access to the API server to do certain things, right? Now, I see an interesting question in the chat window that, right, without me using the API server, how can I connect or how to access the pod, right? You have to go through the API server for any of the administrative activities. There is no other way, right? For any of the administrative activities, I'm fetching the word called administrative. When I say administrative activities, is mean that creating a pod, deleting a pod, not even pod. Why do I worry about the pod here? I always worry about my deployment, right? So creating a deployment, deleting a deployment, updating a deployment, right? Or patching the deployment, creating a service, deleting a service. All these are called as a administrative activities. Will definitely be done through API server only if you wanted to do from your administrative perspective by manually. Either whatever the case, either you run kubectl or any other way, it has to go through API server, right? Those are the administrative activities. Now, if you wanted to access the application, that's a different thing, right? Accessing the application that is running in the pod, that is not related to administrative. Getting me right? Let's say I have one web application is running in the pod. I wanted to access the application from my browser, www.edshopper.com. That request is not going through the API server, right? That is the client request would like to access the port number 80 of the application that is currently running. That traffic will go via the Route 53 to AWS load balancer to node port to a service to your pod using the label concept, right? That's how we need to understand the differences here. So I'm introducing the ingress controller, right? The ingress controller is a customized tailor-made application that is supported by your Kubernetes to run inside a cluster that will be taking care of routing the traffic to the backend services of type cluster IP, right? Why do I need to use cluster IP here? As I said sometime maybe in last lecture, right? The service that I'm creating here to access my pod, this service is actually be available only within the cluster. My service need not to be accessible to outside directly, right? So that's the reason it is a cluster IP. Who is now taking care of getting the traffic from outside to inside? Here, the ingress controller is now taking the responsibility of getting the traffic from outside to inside. The ingress controller is actually doing two things. One, the ingress controller will take care of deploying one load balancer type of the service to integrate with the AWS load balancers. Plus, whatever the traffic that it is receiving, it is actually routing to the backend cluster IP services based on the rules that you define. Now, if you closely look at here, right, the ingress controller is actually trying to interact with the multiple services, correct? The ingress controller is now responsible to do certain, to do certain Kubernetes related operations, to do some traffic routing, interacting with the different services, all whatnot. So this is where the ingress controller may need to connect to the API servers to administrate this type of effort, guys. Possible, right? The ingress controller in the cluster, there is a API server, right? API server is actually overseeing the whole effort to make the things are happening correctly, correct? So here, the ingress controller application may need to connect to the API server to manage the stuff here. That is where the pod where my ingress controller application is running, that pod may need to have a service account to connect it to the API server, then only the whole stuff can be manageable. This is one example for now. Why do we need to use the service account option? And why do I need to give the API server access to the pods? Getting me? This is one use case. I'll show you what does it mean now. Let's say now I wanted to deploy the ingress controller, right? So let's see how to deploy the ingress controller. Of course, obviously, you need to create a manifest file, right? Correct? Right? So if you look into the Kubernetes documentation and look for the ingress controllers, which will be helping you to ingress the traffic from outside of the Kubernetes to inside the Kubernetes. That is what the ingress is doing here, right? So this ingress controller, you see here, you can deploy a K8s application gateway ingress controller, Alibaba Cloud MSC ingress controller, Apache, no, AP6 ingress controller. You can see there are many, guys. You can use any ingress controller that you like it out of this whole bunch of list to make this happen. There are many if you go in the list, right? Because if I come back to this architecture one more time, right? In my case, I am using the AWS cloud as an infrastructure provider, right? But not all the cases, right? You may be using the Google cloud as an infra provider, or maybe a Azure cloud as an infra provider, or maybe a on-premises, correct? Why it has to worry about the infra provider here? Because the ingress controller should be binding to the external load balancers, correct? The ingress controller should be somehow getting the traffic from outside of the external load balancers, because the external load balancers are giving the traffic to the node port level. From there it is actually picking it up. And in my case, I'm expecting that, right? When you deploy the ingress controller, it automatically creating the AWS load balancers as well for us, right? So somehow it has some dependencies with infra as well, correct? That's the reason there are multiple ingress controllers are available here based on your project requirement, what kind of the cloud that you are using. You may need to take a decision which one will be the best choice out of all this list, right? Out of all these, the most recommended ingress controller is Nginx and Istio, right? So very a few projects are using HA proxy, but I would say 80% the people are using Nginx, maybe 15% the people are using Istio, maybe 5 to another, right? 5% the people are using HA proxy as well. But more or less all these are doing the same job for you, right? It's just the different providers, but the concept is same. Following me, right? So let's say I would like to deploy the Nginx ingress controller for my Kubernetes, which is the most preferable choice for most of the projects. So let me click on that. So this is where it is landing now. It actually a Nginx application. Nginx is a kind of the web service application. It can act as a proxying the request as well, right? So the Kubernetes is actually, taking this Nginx open source application, and they are doing some changes on this to make it working as per their custom needs. Okay, this is all the bunch of architecture how it works. We don't need to worry at this time. Try the ingress controller. Kubernetes Nginx ingress controller. I just searching for the right documentation, guys. Okay, so here I can see some documentation on this, and somewhere you can see the. I'm just worrying about the manifest file, right? How to write a manifest file for this. These guys are changing this very often. So installing with the manifest, and let me go to this section. I'm just following this documentation. So this is where I got landed in. And yes, now if you see this, right, this documentation will help you on the manifest file. Correct, guys? What is that you need usually to deploy something on the Kubernetes? It all a manifest file, right? Agree with me? Right? So here you can see a manifest file. It's not, of course, we need to spend some time to get into the documentation, read it, understand it. I'm just quickly trying to find it one. And you see that this is a kind is deployment, a app/v1 is the API version, metadata, spec section, replica count is one. And you see all this different stuff here. And just go through this. Somewhere you see that the image, it is actually getting the Nginx ingress image from the Docker Hub registry. It is getting the Nginx ingress image from the Docker Hub registry. Then they are doing some tailor-made on this, right? On this Nginx ingress image, they are just doing some configuration at Kubernetes level. So finally, it will work as a ingress controller for you. So we don't need to worry too much about this whole manifest file, because if you see this manifest file, right, it has almost 114 number of lines, right? It has a lot of stuff. We don't need to know line by line. So they have done some tailor-made on the ingress image that they get it from Docker Hub, and they just made it readily to use a manifest file for us, right? This is just a deployment file, guys. Again, it has few other files as well as a supporting, right? So we need to combine all those manifest files together and start using. You see, under the deployment, you can see a deployment file, and under the RBAC, you will be seeing some RBAC related configuration. Under the service, you may see some of the services that you need to use. So combining all these manifest files under the service, under the RBAC, under the deployment, and under the common, right? If you combine all of them together, you will get a actual manifest file final to run it. That's how we need to do some little workaround, right? Of course, there are some easy ways as well, but as of now, I really wanted to get started with from scratch, and this is how it is. So just to make your life easier for now, right? Because I just need to go and get the manifest from here only. You see this? This particular file is combining, is having, right, the manifest file to create a namespace. You see, guys, this is the namespace, right? The kind is namespace, and this is the name of the namespace. It's possible to have multiple manifest in one single file as well. You see, hyphen 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 is the separator. So the above one is one manifest, and the below one is the second manifest. It's possible. You can keep multiple manifest in one single file as well by using this hyphen 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 as a separator, or we can put in different files. It's up to you. How do you manage it, right? But at high level, this file is trying to create a namespace required to deploy the ingress controller. Is it make sense, guys? In a last lecture, right, we were talking about dev namespace, QA namespace, production namespace. The namespace is a logical right concept to group my pods. Now tell me, the ingress controller will belonging into dev or QA or perf? I'm trying to deploy a ingress application. Like, how do you deploy your Apache web application to serve your website? Same way, ingress controller is one application that I'm trying to deploy. What is the purpose of this application? This application purpose is to give you the ingress capabilities, right? This ingress is not specific to a dev, not specific to perf. This is at a cluster level, correct? This works at a whole cluster level. That's the reason it's better to keep it in a different namespace. Got me? I'm not deploying it into a dev or QA or perf. I'm deploying it into its own namespace. That's the reason they are actually creating a separate namespace here and start deploying this application on that namespace only. That's the purpose of namespace. That means don't think that the namespace is just for the dev QA perf environment specific. No, Namespace is just a logical concept to make your applications are unique without conflicting any other, right? So this is deploying it into a different namespace, right? Just to make a complete isolation. I mean to say, it's better to manage the applications segregated by the namespace level. Anyway, so if you look into some other files here, right? This one, right? This is actually deploying the ingress class. That means it is telling that, hey, I wanted to use the ingress in order to do the routing concept, something like this. And the deployment file has the ingress deployment, right? And if you see the service concept, this is where you can see the service of type load balancer, which will be creating the external load balancer for you, like that, right? So what I did here is, whatever they have talked about in their documentation and whatever the files that they have given here with the different set of files to deploy the whole ingress controller, I actually combined all of their effort it into a one single manifest file. And of course, as I see a question, right, usually if you don't specify the namespace, it by default it will be getting into the default namespace, because without a namespace you cannot deploy anything in the Kubernetes. Anything must be within your namespace only. If you don't specify, it will go to default namespace. That way it will ensure that at least some namespace is assigned for any of the deployment, right? So if you want to deploy this ingress controller, right, so I need a manifest file, correct? So let me go to, where is the ingress manifest file? So this is where I have collected the manifest file from the documentation and I combined it into a single file. I'll show that file here. I will say this is a controller.yaml file. So at finally, if I look into my ingress controller manifest file, it has got total 682 number of lines, guys. That's the reason I think, don't think how this manifest file is written and what is the line by line to understand it, at least for now. Once you be expertise on the Kubernetes, maybe you can revisit and start looking line by line. But for now, it is just a 600 plus number of lines manifest file to deploy the ingress controller. I got this whole bunch of 600 plus number of lines from their documentation only, nothing that have written any single line, right? But at a high level, if I look into this manifest file, they're actually creating the namespace in which namespace the ingress controller has to be deployed. Now you see the service account concept here, right? So they're actually creating a service account, this service account to ensure that, right, this service account will be get attached to the ingress controller pod, so that that pod will get the permission to connect to the ABA server in order to do its ingress related responsibilities, getting. And that is the service account. And somewhere you can see the role. This is how they are creating the cluster role, and they are giving the permissions, right, for the different Kubernetes resources, and they are giving the list permission, watch permission, just for reading purpose, something like this. So don't worry, a line by line at this time. I'll show you how to create a service account, how to create a role explicitly a bit later, right? Not as part of this ingress controller deployment. For now, I'm just taking by default as per their documentation, and I'm just deploying as it is. This is the role binding concept, as I said some time back, and this is how to create a role, right? And if I do little scroll down, this is the role binding, something like this. This is the service, right? The cluster IP service, and this is the another service, which is the load balancer type service. You see this? They're actually creating one load balancer type of the service. When we are creating the service of type load balancer, right? This service can have a annotation. Annotation is a concept in the Kubernetes which will be setting certain characteristics for this resource, how it has to work on. I mean to say, let's say I wanted to deploy a service of type load balancer. This load balancer type service will go and create a load balancer in the AWS, right? Let's say what kind of the load balancer that you are expecting. Is it a classic load balancer, or a application load balancer, or a network load balancer? Getting me? That means what kind of the load balancer that you are expecting. That is what I wanted to tell. But is there something related to Kubernetes, guys? That's not a core Kubernetes concept, correct? At least, right? That's not a core Kubernetes concept. Like what kind of the load balancer that I'm expecting to be created in my AWS side. That is not a core Kubernetes concept, right? The Kubernetes concept is what? Create a service and distribute the traffic to the pods based on the labels that it is matching. That is the core concept. Anything that we are doing additionally, right? That is not a Kubernetes concept. Those extra override permissions or the override characteristics that you are expecting, all those things can be given as a annotation format. If you look into the annotation here, right, in the annotation, I'm telling that at a high level, what kind of the load balancer that I'm expecting. You see here, AWS load balancer type. This is the annotation. This annotation value, I'm keeping it as NLB. So I need a network load balancer. If you need the application load balancer, here you define ALB. So that the application load balancer will be get deployed. That kind of the characteristics that you wanted to overwrite to the default behavior, all those things can be given in the annotation section. This annotation section is not just for a service, guys. This is the general Kubernetes concept. You can give the annotation for any resource, for deployment, pod, service, whatever, right? It can be given. But how do you know what will be the annotation name? You see, I'm using something called service.beta.kubernetes.io. What is this? How do I know that this is how I need to give the annotation? And these are the annotations that will be supported for this service. What kind of the values that I need to give, correct? At least by now, you know what is annotation, right? Annotation is all about overwriting some of the default characteristics, how your resource has to be working or behaving. Those things can be given in the annotation section. To get more information, what kind of the annotations that this service can accept, you need to get into their documentation. Kubernetes service annotations. So their documentation will help you the bunch of annotations that they are supporting. All right. So somewhere you can see if the type is service so on, you see this is the annotation. And this annotation is the example to tell the load balancer to be a internal or a external. You see, you need an internal load balancer or the external, in the sense internet facing load balancer. What kind of the load balancer that you are expecting? These annotations will be keep varying based on the cloud that you are using. If I go for Azure, you got a different annotation, right? So we need to spend some time in understanding how do we specify the annotations and what kind of the annotations that the document is supporting, and accordingly you need to go and put the things here, guys. That's how it works. Of course, a lot of research would be needed to compose your final file, but at least now I got the file, I got the syntax, everything from their Nginx documentation, and I'm just trying to explain you what it is and how do you get this information. Usually you need to rely on their documentation only. Yeah, so that's a high level for now, right? And I can see the deployment. This is where it is trying to deploy the ingress application, right, from image, so on, so on, so on, so on. For now, without worrying much about this file, let me go and deploy this. Some of the columns or some of the rows that you see in this file get clarified in later sessions as well. So for now, let me just deploy blindly. I'm just deploying the ingress controller. kubectl apply -f controller.yaml. How many of you can understand this error, guys? Basically, kubectl is not able to connect to API server, okay? Because I need to run this command. AWS EKS update -kubeconfig -name EDEKS EK01 -region ES East 1, because I'm creating the cluster every day, right? Done. It actually created namespace, service accounts, right? Some roles, role binding, all these things, right? And deployment, lot many things. We don't need to worry about all of this, at least for now. Just think that I just got my ingress controller manifest file, I just executed. Good, because I'll go back to these in later to give some other insight. So let's see what has happened now. kubectl get ns to see the namespaces. I can see a namespace called ingress -nginx 32 seconds ago. Good. kubectl get pods. I wanted to see the pods running in this ingress -nginx namespace. You see that there is a ingress controller. Ingress nginx controller is currently running for you. Good. This is the pod. This pod is connected with a service account to get a permission to the API servers. All this taken care of as part of your manifest file deployment. kubectl get service. I wanted to see the services on this namespace. You can see that there is one service deployed of type load balancer, which is actually binded to a external AWS load balancer for you. This load balancer definitely a network load balancer, because in the annotation I defined that I need a network load balancer, right? It might have been created a network load balancer for you. With that, the ingress controller is done. What will happen now, guys? If you wanted to access a website, right? Let's say this is the load balancer endpoint that you need to use, correct? Getting me? From outside world, now if you want to send your traffic to inside a Kubernetes, right, you just need to send the traffic to that particular load balancer endpoint. That load balancer endpoint will ensure that the traffic is given to the worker nodes that will be captured by whom? That is captured by a load balancer type service, which is now controlling by a ingress controller. Hope you are following my vocabulary. I mean to say the terminologies. So let me do this implementation. Let's say I wanted to access my website. All what I do is I'll go to my DNS, right? Let's say www.edshopper.com that I wanted to access, right? The resolution should be done for your AWS load balancer, which is got created automatically by your ingress controller. Now save it. You can see that load balancer as well in your EC2. You see this is the load balancer that is just got created. The type is network load balancer, right? Usually if it is network load balancer, there will be a target groups like application load balancers. You see there is a 2 target groups that are created for you. Each target group will have a EC2 instances as a targets. All the stuff is done for you. So far so good. Now with this, whenever you run a website name in the browser, the communication will come to the AWS load balancer. AWS load balancer will give to worker node that will be taken care by your ingress controller, correct? I did this till this level. Now let me deploy my one of the Apache web server. Then let me try to access this. Now I'll go and deploy my Apache web server, guys. Maybe I wanted to deploy it in the dev namespace first. Okay. I wanted to deploy my application in the dev environment. I'll copy my deployment manifest file. Sorry. kubectl create a namespace dev. What I'm doing, I'm deploying my business application it into dev environment. I have a dev namespace. Now let me run kubectl apply -f deploy.ml. Sorry. You see, if you don't specify the namespace, right, what will happen, guys? That's why I deleted again. You have to specify the namespace, in which namespace that you wanted to deploy. Apply, right? So on the dev namespace, now my application is deployed. How to access this application, guys? No clue. I deployed a ingress controller. This component is done. When you deploy the ingress controller, that took care of creating a AWS load balancer automatically. Now I deployed a deployment that took care of creating a pod. How do you access the application running in the pod? Forget about your www.edshopper.com, right? In general, we always think from the like administrative perspective, right? To access the application that is running in the pod, you need a service. That is what the Kubernetes is expecting, right? This service I wanted to deploy now, this one, right? As of now, I deployed only the deployment, and that will run the application. The ingress is just to get the traffic from outside to inside. But now to access my application, I need to deploy the service. Tell me what kind of the service that you wanted to deploy. So here the same service manifest file that we have done before. The only change here is the type will become cluster IP, because this service will be accessible only within the Kubernetes only, not from outside. No one will be binding this to external world, right? Because in my architecture, the ingress has one service of type load balancer, right? That will take care of getting the traffic from outside. So from this service, I wanted to connect it to another service. So within the Kubernetes, the cluster IP. When you are deploying the cluster IP service, right, do you need to worry about the node port? While you are thinking, I'm just checking the labels, guys, like which label that I have given in my deployment, because I need to use the same label in my service also. Yeah. So do I need to worry about the node port now? No, right? I don't need to worry about the node port because I don't want my service is binding to the node port directly, no, because from the node port already ingress controller is deployed to take care of. So hence the reason I'm removing this node port concept. Then just say that what is my cluster IP port and what is my backend port where the pod is listening on. That's it. And looking into the question in the chart window, the AWS load balancer is already created, which is created by using the ingress controller, right? When I deploy the ingress controller taken care of deploying the service of type load balancer, that taken care of creating a AWS load balancer. This whole stuff is already done, right? So this highlighted whole stuff is already done, and using the deployment, the pods are running. Now I'm just deploying the cluster IP service. This is just a service to take care of routing the traffic to your backend pods based on the labeling, right? So far so good. Now I'll just get my cluster IP service manifest file. kubectl apply -f service.yaml file. I wanted to deploy it into dev namespace. kubectl get the service on dev namespace. On the dev namespace, I have the service. The service name is my service. That's the name. The service of type cluster IP. It has its own IP and it is listening on port number 80. Good. What else, guys? Now, whenever you run, maybe as per our example, right? Whenever you run www.edshopper.com, the traffic will be resoluted to AWS load balancer, correct? We did it already. Whenever the traffic come to AWS load balancer, that will be coming to my ingress controller, correct? Now, the only leftover part is I need to tell to my ingress controller that, hey, ingress controller, whenever you receive a traffic from www.edshopper.com URL, can you please forward route the traffic to my cluster IP service? That is something that is now pending, correct? Which is called as a ingress resource. Technically, we call it as a ingress resource. Ingress controller is different. Ingress resource is different. I think let me do this because I created this presentation for explaining the advantages of ingress controller, right? Usually, if I go for the presentation, all those other extra load balancers will be get deleted as part of the presentation. Finally, you will see only one AWS load balancer. That's how it works. The load balancer type will be get removed by the cluster IP service. That's how it will help us for the presentation. So if I come out from the presentation mode, right, you will get to see all those extra necessary stuff that is sometimes confusing. Understood, right? Yeah. So now the traffic is came to AWS load balancer and then it is coming to the ingress controller. Now I just need to tell to ingress controller that, right, hey, whenever you get the request, you please forward that to a specific cluster IP. Once the request come to cluster IP service, then that take care of giving to the pod. So how to do that? So I need to create a ingress resource. Ingress resource is different. Ingress controller is different. Ingress controller is just to get the traffic from outside. Ingress resource is the path-based resource which will be taking care of routing the traffic to the specific service that you are looking for. Now let me show you how to create a manifest file for ingress resource. This ingress resource you need to do for each service. How many services that you have? You need to create that many ingress resources. It will be like this, right?
Is
The
it
API
again
version is
chargeable, sir?
always,
Ingress?
let me come back, guys. Let me come back to this. Now a quick question. I'm okay to answer the question at this time. A quick question for you. Who will be charging for this ingress controller? Of course, let's say if this is chargeable, who is charging? Do you think the Kubernetes will charge or AWS charge? Just a logical think process. Okay. Okay. If you say AWS, right? Let's say AWS is trying to charge for the ingress controller. How do the AWS will charge for it? AWS will only care about, hey, how much processor you are taking, how much memory that you are taking, how much storage capacity that you are taking, how much data that you are transferring. I said these are the four major components that the AWS is looking for to take a price from you, right? That means what?
Yes.
There's nothing like a charging for a service, nothing like a charging for ingress, nothing like a charging for whatnot, right? At the end of the day, it's just matter of how many worker nodes that you have running in your cluster, how much compute that you are utilizing, and that reflect your AWS bill. That's it, correct? This is the whole sarcasm happening within the Kubernetes level, right? At the end of the day, it's just matter of for AWS, because everything is running in the AWS, right? So the AWS will just see, hey, how much that you are using from me. That's it. From the compute perspective, storage perspective, and the network perspective in terms of the data transfer, bandwidth, all these things, right? It doesn't care about you are running ingress or a service or something else, right? Because it's all running in your EC2 instances only at the end of the day, right? I hope that clarifies. Thank you. If I come back to this, right? Yes, the API's version is networking.k8s.io/v1. So again, just a documentation says that this is how we need to use. The kind is ingress, and you can go with whatever the name that you like it under the metadata. This is the line number 5, that is where you need to tell that this ingress has to be created in which namespace. Your application is running in which namespace. You define this ingress resource in the same namespace. In my case, my application is running in the dev, so I'm deploying this ingress resource in the dev namespace. And what is the host name that you're looking for? www.edshopper.com. That means, hey, if anyone is accessing the website using this name, right, can you please send the traffic to this service? My service name is my service, right? In this case, correct? You see my service name is like this. I'm taking that. and specify the service name and specify the port, right? The service is listening on which port number. This ingress resource should be using by whom. The ingress resource means what? The ingress resource is all about if the request URL is www.edshopper.com, then that request should go to this service on this port number. That is what is the meaning of this particular entries. So this path-based rules, this ingress rule should be used by whom? This rule should be used by ingress controller, correct? That should be used by ingress controller. So that's the reason in the configuration you need to tell that, right? Who should be using this ingress class name? And of course here I'm creating one. So I'm actually creating a ingress class with the name called Nginx, and in the spec section I'm telling that ingress hyphen Nginx is the controller name, Nginx controller name. This is the ingress controller name, guys. So this is the ingress controller name that I'm creating as one of the ingress class, and please use that ingress class to use these resources or whatever the definition that you have given. That is how it works. So whenever you deploy the new service, you just need to worry about this configuration. Most of the things will be same. Just worry about your URL, which service, which port number. But this is how it works. So technically speaking, what I'm doing, I actually deploy the ingress controller, then the ingress class, then the ingress resource. That's how it works. Maybe it's a good idea to create a one more slide out of this, and I'll just try to remove some unwanted stuff from there. Right, so this is what's happening. So here in the ingress controller section, right, we are actually creating what? We are creating the ingress controller, correct? And we are creating the ingress class, right? And we are creating the ingress resource. And simply we'll call it as ingress. This is how we are creating multiple things actually. So strictly speaking, this is how it works. You see how many layers are there, right? So not even like this. So I need to do one more.
So for every ingress controller defined at cluster level, we should have all this structure, right, sir? In its YAML file or manifest file.
Well, you see these levels, guys. So whenever the traffic come to the AWS load balancer, somehow that will be coming to my service in the Kubernetes of type load balancer. Then that will be overseeing by your ingress controller. From the ingress controller, there is an ingress class is created. From the ingress class, you actually created a ingress resource. In the ingress resource, you defined the traffic should go to where. There you define that, hey, the traffic should go to so and so service, and that's how the things are routed, right? Let's say if you have another service, for example, you have a application 1 and application 2. Now all what you need to do is just create a one more ingress resource. That's it. The remaining everything will as it is, right? The remaining everything is as it is. I meant to say you create a ingress resource. This is the second ingress resource, and you tell that, hey, you please use the ingress class. This is one single ingress class for one ingress controller. That's it, right? And tell that how the traffic has to be routed. That will be routed. You see, I have two applications. I have two ingress resources. The ingress controller, ingress class, load balancer type of the service, AWS load balancer. This everything will remains be a one single set only. We don't need to create multiple times. Yeah, that's how it works now, right? So the ingress class, ingress controller, LB, and this whole is one time activity only. Each time when you deploy the new application, you just define the ingress. In the ingress, you define, right? In the ingress, you define which URL should be mapped to which service on which port number. You define the ingress class name over there. This portion you don't need to use every time. Since I'm using this very first time, I'm just representing that, but we don't need to use that every time. Just say that, hey, this is the class that you need to use, because that class is already created and that is one-time activity for every ingress controller.
So that arrow mark should be up from the ingress class to the ingress, right? There.
Of course, what not? That's okay.
Sorry. So I thought, under ingress class, there are different ingresses that we create for each service, right? So
yes, that's true. Of course.
Yeah, thanks.
Right. This is how the whole structure works, right? But for now, let me deploy this because I need a output.
PR, who invented Kubernetes?
It's not me, definitely.
No, I want to shoot that. I want to shoot that person.
Right. This is the Google product. Right. This is the Google product. Okay. Google has did this thing. So let me deploy this. kubectl apply -f ingress.yaml, and I wanted to deploy it into dev namespace. I think that already created. Done. Now you see kubectl get ingress on dev namespace. Looks good. In the dev namespace, now if you see, right, if anyone is using www.edshopper.com, that will be actually, right, taken care of by your ingress class, right, and the respective port numbers, all these things. Now if you use this website, you should be able to access the website. Here you go. So this is working now, right? www.edshopper.com is now working. So now if you look into this hierarchy, yes, that request, that website is coming just to see this, and of course it's a funny thing, just to see this online website, at least for now, right? While what I'm doing here, the traffic is going to AWS load balance. Of course, traffic is first, your URL is going to DNS resoluted AWS load balancer, then within the Kubernetes LB service, then it is handling by your ingress controllers with the help of this ingress class, then the ingress resource that will take care of how to route the traffic, then to the cluster IP service, then to the pod, and then inside the container, then inside the application that will be responding back to you. Right.
So one doubt here, this ingress, for the ingress class, we are not using any manifest file, right?
we are using.
I think
So this is what I have shown you, right? This one. You see the kind is ingress class. I just combined these two it into one single file actually.
oh, okay.
Okay. With the separation of hyphen hyphen hyphen, we can combine multiple it into one itself. If you feel like these two manifest files are can go together belonging into single use case, we can put into one single as well, not a problem. I just used it here. Right, and believe me, you don't need to go deeper and deeper just to see what the ingress class is doing, what the ingress control is doing exactly. At high level, yes, it is actually trying to get your traffic and trying to do some distributions, right? Now, keep you on mute, guys. Now let me come back and see if we have solved all the problems that I wanted to. Where do I need to come? Okay, so maybe we'll try to do some checklisting, guys. And of course, of any application that you are trying to deploy, right, you need to ensure that as a good administrator, if my application is highly available, are we getting the highly available application, guys, using Kubernetes as of today? The very first checklist is it highly available, right? Is it highly available now, your application running in your Kubernetes cluster? Yes, it is. Then who is responsible now to make this as highly available in Kubernetes cluster? Right? Who is taking care of that? Your deployment. And of course, with the help of the replica set only, but since I'm not I'm not directly working with the replica set, just from user perspective, so my answer is deployment, right? But yeah, if I go in deeper of the technical guy, the answer will be like, yeah, replica set controller. But the replica set controller alone is doing this? No, right? So to make this as a highly available application, right, your service is also playing the game here to route the traffic to the backend pods, correct? What if your deployment or a replica set controller is creating some 3 pods or 3 replicas or 10 replicas? But if you don't have a service to route the traffic to those pods as a round robin fashion by looking for the label match, do you think your application will be serving to multiple pods? No, right? Correct. So your service is also playing the game here to route the traffic to the multiple pods whenever you have multiple pods. And if one pod is down, the service will know how to route the traffic to another one, right? And of course, as cluster IP service too, right? That's one thing. But when I say highly available, right, this is not just about the pod failure. If the pod is failing, yes, there is another pod who can take care of the traffic. I agree. But sometimes your worker node may also get failed, correct? Is that highly available still? I do believe yes, right? If my entire worker node is down, still my application is highly available because the application may run in another worker node wherever it is healthy. The Kubernetes is already automatically taking care of that, moving the pod from the failure node to the healthy node and all. Right? That means highly availability is taken care of, right? Uh, the self-healing is taken care of. service discovery is taken care of, right? And automated deployments are taken care of, in the sense I'm not worrying about how to run my application, where to run my application, right? In general, you just tell to Kubernetes that, hey, my application has to run. Let Kubernetes handle how to run, where to run, correct? You are not really worrying in which worker node the application should run. It has some default scheduling policies to take care of. So most of the things are covered except one, which is the scaling. Do you think, did I solve the scaling related problem? No, right? I did not solve the scaling problem yet. What does it mean? Let's say currently in your Kubernetes cluster, my application is running with the 3 replicas. The 3 replicas is the constant static number that you given in your deployment, correct? So it always run with the 3 replicas only. But what is the case if more people are trying to access my website? If your pod is not capable to handle the load, then pod will go crash. Pod cannot handle the load, the usage is high, the pod will go for restart or it will go for crash. Again, new pod will be get created because of the crash. All these things will happen now. I mean to say, if there is a more load is happening on the pods are not scaling here. The compute is not scaling here automatically, correct? How do we solve that problem? Because in the deployment manifest file that we are not solving, right? In the deployment manifest file, I'm giving the replica count as a static only. How do you know the replica count will be 3 or 10? Which number will be an ideal number to, to meet the demand, correct? So that's the reason the scaling is not taken care by your deployment alone. To take care of the scaling, we need to depend on a horizontal pod auto scaling concept. In technically, we can call it as a HPA concept, right? Horizontal pod auto scaling. This HPA is now the responsible guide to scale your pods automatically. That means, let's say it is now running with the 3. If there is a more demand, more load, automatically the 3 pods will become 5 pods, may become 7 pods, 10 pods, whatever you define in a HPA. That is called as a scaling. On what basis the HPA will decide the pod has to be scaled? Obviously, help me guys in the chat window. When do you think the pod has to be scaled? Right? When do you think the pod has to be scaled? Right? Whenever the compute utilization is reaching maybe more than 90% or 95%, then I need to do the scaling, correct? And of course, whenever the more number of users are accessing my application, then I have to do the scaling. But in general, from the application perspective, I don't care about the number of requests, right? I care only about whether my pod has the enough amount of processing and the memory capacity available or not to serve the traffic, correct? Hence the reason, and of course, the number of requests is directly proportional to the consumption. That is true. So from the pod side, I just worry about the processor and the memory. So whenever the compute utilization is go beyond the threshold, then we need to understand that the pod is not capable to serve the load because of the more usage. Let me do the scaling. If then your HPA has to follow the same concept, the horizontal pod autoscaler should monitor the CPU utilization of your pod, correct? Same concept. We did this before as well, right? And it's general. If the HPA has to monitor the CPU utilization of a running pod if the usage is go high, beyond the threshold, okay, the time for doing the scale out. Whenever it sees that, hey, the usage is less, the time for doing the scaling. You define minimum how many it has to maintain, maximum how many it has to maintain, the number of pods. You maintain the configuration in your HPA. Make sense, guys? That's what is all what we need here, right? This is actually be taken care by the AWS auto scaling with the help of the CloudWatch alarms if your application is running in a direct EC2 instances, correct? But here, since I'm running in the pod, my pod has to be scaled, so I'm using the HPA concept. The problem here is the HPA, right? The HPA cannot go and get the CPU utilization or a memory utilization of your pod directly. Why? At first place, right? In general, do you think the Kubernetes has the access to go inside a container to get the application in general? No, right? So if you go in a very deeper, right? Because to get the CPU and memory utilization, right, it has to go inside a container and get the metrics in general, right? Kubernetes is not going to that level just to get the utilization, at least basic native Kubernetes. So that's the reason to get the metrics of your compute resources, right? We need to deploy another add-on software, which is called as a metrics server. Of course, HPA is responsible to do all of this, but HPA need to monitor the pod, right? To monitor the pod, we need a metrics server. Without a metrics server, HPA cannot monitor the pod. As and when we see the things are getting complicated, there are few more things are coming up to make us more confusing, right? You see here, this is the metrics server official page where you see the metrics server related source code, all these things. This will explain you how to use the metrics server. The metrics server responsibility is to monitor your pod and give you the container resource metrics like processor and memory metrics. Once this metrics server is exporting this resource utilization, that information will be used by the HPA and will take a decision on top of this. Just a thought. Go back in your AWS concept just to understand why, because whatever the best practices that you usually do on a AWS when you run an application directly on EC2, right? I'm applying the same best practices again in the Kubernetes in a different way, correct? In a AWS, the AWS auto scaling group is the responsible to do the scaling of your EC2 instances, correct? But do you think the auto scaling will do the whole responsibility, monitoring, alerting, scaling? No, right? There, the AWS auto scaling was depending on the CloudWatch in order to get an alert to be created, because the CloudWatch is responsible to monitor and alert. AWS auto scaling is responsible to listen to that and do the scaling, correct? Same thing here as well. The metrics server is now responsible to monitor and give the details. The horizontal pod autoscaler is responsible to get the data from the metrics server and take a decision and do the scaling for you, right? Now, how to do this metrics server? So this documentation will explain you how to deploy the metrics server, and you will see the metrics server related manifest file in this particular link. If you go and look at this link, right? Yeah, I think file is downloaded here, right? You see the file. I got one file downloaded. If I open the file, this is your metric server manifest file. Again, guys, this metric server manifest file is having almost 200 plus number of lines. So don't worry how it is working. Just take it and deploy and run it. Right? We are running as it is. Just take this, which I'm getting it from their documentation, and just run it. Even you can run the command as it is. You see, kubectl apply -f. They are giving the HTTPS link where the metric server manifest file is there. It can download the manifest file from that link and can apply directly. You don't need to worry about anything. You see, it is now deployed the metric server. The thing is, it will create a namespace for you. You see again, not really. Sorry.
Is vertical scaling also possible other than horizontal?
Yes. You see now the metric server is actually deployed. I can see that metric server pod is running. So this pod is now running the metric server software or metric server application. This metric server application is now responsible to give you the capability to monitor the pods, all these things. This is actually deployed in the namespace called kube-system. I think I'll talk about this namespace in a while, but yeah, somehow I can see that the metric server is currently running. So once you deploy the metric server, right, you can use the command called kubectl kubectl top pod. I wanted to see the pods in the dev namespace. The kubectl top command will be working only if the metric server software is deployed, or else it will not work. Now you see that each pod is utilizing how much processor, how much memory. You are able to see this metrics now. Get to repeat. The kubectl top command will work only if the metric server application is deployed, or else it will not work. The metric server will monitor the utilization at each pod level. It can monitor the utilization at a worker node level. You see, this worker node is currently utilizing how much processor or how much memory as well. This is at a server level, and this is at a specific individual pod level. Now, because there is a way to utilize, there is a way to see the utilization of each and every pod. Now I can tell to HPA that, hey HPA, you go and look at the CPU and the memory utilization. Whenever the resource is going beyond the threshold, you please do the scale for me. That's how it works. Right? And of course, the metric server, ingress controller, those are again applications running in a pod like your Apache web server, correct? Possible. Even those will be get crashes. The metric server pod may go for crash. Ingress controller pod may go for crash. You maintain the uh, replica count for them as well to get a high availability, right? For now, simply I'll go and deploy the HPA, guys. You'll get to know what it is. How to deploy HPA? Again, a manifest file. So this is the documentation to deploy the HPA, horizontal pod auto scaling. So you will get to see where it is. Because once you go to one level, right, you can't write manifest files for all these. You need to get from their documentation only, because these are the standard ones. You need to create a manifest file only for your specific business specific applications. These are a very standard one, right? So you can get it from their documentation only. That's okay. I'll get it from my repository. I think under the manifest file, it should be other section hpa.yaml file. Again, I get this from documentation only, guys. For now, I'm just quickly getting this. So simple. The kind is horizontal pod autoscaler. You give the whatever the name that you like it for this HPA. All what you need to worry about here is minimum replicas, how much that you are expecting, maximum replicas, how much that you are expecting, when the scale has to be done. You say whenever the CPU utilization is more than 50%, then you please do the scale out and go maximum of 10 pods. If the usage is less than 50, you please maintain only one replica. That is how you are defining the minimum and the maximum replica counts that you are expecting for your application and the condition as well. That's it. Which one it has to manage? That's where you specify the target here. The kind is deployment, and this is the deployment that you need to manage. In my case, what is the deployment name, guys? This is the deployment, right? My deployment name is web, correct? So you specify that, hey, my deployment name is web. So this web deployment, you please maintain 1 and 10 replica count. And this is the condition when you need to do the scale out. So just give that this is my web HPA. Where it is running? It is running in the namespace, right? You can specify the namespace as well here. It is currently on the dev namespace. So again, you can specify the namespace in the metadata section, or you specify the namespace at the time of you are applying this file. Both are same. For example, now let me deploy this HPA. You see, when in the apply command, you define -n and the namespace, in which namespace that you are expecting this to be get deployed, or you can specify the namespace in the metadata section as well. Both are same. It is complaining, guys. It is complaining that auto scaling slash v2 beta 2 is not a valid one. It's complaining that horizontal pod autoscaler, the API version is not the correct one. How do you get that fix? How do you get that fix? I already talked about that, right? It's all documentation only, nothing else. So currently we are using 1.28 Kubernetes. I will go to 1.28 documentation only because this is very important. Manifest files that you have written for one Kubernetes version may or may not be working for another version, guys. The manifest file that I'm taking from my documentation may be working that time, but may not be now. Why? The Kubernetes version is changing. Now let's see what is the latest configuration for 1.28 version. And what is that I'm trying to deploy? I think this is very important link that you need to keep it handy, guys, because it has everything. You see, I want to deploy the horizontal pod autoscaler. Go to that horizontal pod autoscaler. Then you see here to deploy the horizontal pod autoscaler, it will be a autoscaling and /v2. This is what it is recommending. So you need to do the change here. Autoscaling /v2, right? This is the one. It may be working before, but not now. Why? Now I'm using 1.28 Kubernetes. Previously, it may be a different one. That's where we need to always go and get the things from their documentation only. That's the biggest struggle in Kubernetes. Fix that. Now let me run the command one more time. This is deployed. kubectl get pods. Done. Your HPA is deployed. HPA will now take care of doing the scaling automatically for you. Right? You see that the HPA is currently deployed to take care of your web deployment. Minimum 1, maximum 10. Currently it is running with the 3, right? And yes. A question for you at this time. In the deployment manifest file, I said that, hey, I need 3 replicas. In the HPA, I said that, hey, you maintain 1 replica only if at all utilization is very less. What do you think, guys, now? How many minimum replicas that it will maintain? 1 or 3?
1.
Right? Whenever you deploy the HPA to control the replica count of your deployment, the number that you specify in the deployment, this will be ignored. Your HPA will take the precedence. HPA will control this. Right? The static number that you given will not be considered. The HPA will override that number. That will be taken care. So after some time, definitely when it feels that the usage is very less, it will bring down it into a 1 pod only. Whenever the usage is more, it will scale up to 10 pods. When 1 pod is running, when 10 pods are running, who is taking care of doing the load distribution, guys? That giving the traffic to all the 10 pods. Service, right? Service. It's not a controller, it's a service from the concept perspective, right? So the immediate resource that is responsible for doing the load traffic, correct? You see the Kubernetes cluster IP service, right? That is responsible to route the traffic to all the pods, whatever the number of pods, because all the pods may be running with the same label. So that's how it is taken care of. That is the scalability that I have solved the problem. That's the story for today. And before we leave for the session, and a question for you. Did I really solve the problem of scalability at a worker node level, guys? The HPA is solving the problem of your pod level scaling, right? That means if your pod is not capable to maintain, like handle the load, the number of pods will be created. Let's say in my scenario, right? Let's say in my scenario, I have how many servers? I have only 1 server. Good. Let's say in my Kubernetes cluster, I have only 1 node. This node may be having some 2 processors as an example, right? Let's say the more load is came in, your pod cannot go to 50 pods, 100 pods just like that, right? Because at the end of the day, your pod should get the processor and memory from this worker node only, correct? Let's say if your worker node is having some 2 processors, Your pods can get only 2 processes only, right? It is just distributing this capacity to the number of pods. You can't create whatever the number of pods that you like it just like that. So when it reaches to the maximum capacity of your worker node, then you cannot scale the pods also, correct? Hope you are following me. The pods can be scalable only if there is a capacity at your worker node side. If worker node side is there is no capacity, you can't create any more number of pods as well. In that situation, you need to scale the nodes. That means rather running one worker node, you run 2 worker node. Rather 2 worker node, maybe you run with 10 worker nodes. Like that, you need to increase the number of worker nodes if at all you think that the worker node capacity itself is not sufficient to run the number of pods. Agree with me? If you agree with me, and of course, I deployed a auto scaling group. right? I said that the minimum is 1 and maximum is 2, whatever it is. That is true. Auto scaling group should take care of scalability of your worker node. If at all the one worker node is not enough to handle the load, then it will scale to 2 worker nodes automatically. That's the expectation. But when do you think the auto scaling will do the scaling? When there is a CloudWatch alarm is triggered, correct? When do you think AWS auto scaling will do the scale out? When there is a CloudWatch alarm. So do you think, or did you configure the CloudWatch alarm for this auto scaling to do the scaling? Where is the scaling concept, guys, right? Yeah, here you go, right? You see somewhere scaling policies. Maybe I'll just go to edit. Not really, right? So what I'm trying to write, as of now, the CloudWatch alarms are not defined to do the scaling, guys. Because when I did the Terraform deployment to deploy my EKS cluster, right? There I just told that, hey, you please create an auto scaling group. Only auto scaling group is created, but there is no CloudWatch alarm. There is no scaling policies are defined. That's what I'm trying to say. So the auto scaling is deployed without any scaling policies are added. If you are expecting the node level scaling to be done, you need to create a CloudWatch alarm and prepare a scaling policies accordingly. Then only it will work. I'm just giving some disclaimer here. When you create auto scaling group, no, it will not go and work just like that, right? You need to create all those things that we did not do here actually. Makes sense, right? Now coming back to the questionnaire, because I'm done for the today with this beautiful concepts of your Kubernetes, and if any questions do let me know, or else we are good for today.